Good afternoon and welcome in the week 4 problem solving session for the NPTEL course Transition Metal Organometallics in Catalysis and Biology. So from the starting of this course we have seen that this course is mainly a application based course, that is the application of organometallic compound in different field of chemistry. So first we have seen that the DEPE chemistry, that is industrial handling of acetylene and synthesize various important product using DEPE chemistry. After that we move to another important topic is the olefin metathesis reaction. So far we have discussed what is olefin metathesis reaction, the development of mechanism for this olefin metathesis reaction, and now we are discussing the catalyst for olefin metathesis reaction. So in the catalytic path, the olefin metathesis reaction we have seen that undergo metal carbene intermediate, and the graphs designed first catalyst which is air and moisture stable to do this metathesis reaction. Now after the discovery of the mechanism we have seen the aspects of designing the catalyst for this metathesis reaction. So after that the modification of Graph's catalyst came into the picture. So to provide basic steric and electronic control of the catalyst. Also one thing, Graph's catalyst is highly stable in air and moisture rather than other metal catalyst. So now we are focusing on developing the catalytic synthesis approach for this metathesis reaction. So where the ruthenium based catalyst proved to be the best one for this, which is easy to handle. That means these catalysts are stable, they are easy to prepare. Also their preparation does not require any harsh condition, and obviously the major point for this catalyst is the functional group tolerance. That means the other functional group rather than the olefin in the system must be unaffected during the catalytic reaction. So after the Graph's discovery of this catalyst, Shaw also discovered the similar types of catalyst using molybdenum, but the problem is their reactivity is not that much. Okay, so I will wait for another 2-3 minutes. So today in this problem solving session we are mainly discussing the importance of organometallic compound, that is the application of organometallic compound in the major field of catalysis, and will try to develop the basic for the catalytic approach synthesis, and at the last we will see that the process for the cross metathesis reaction and application of cross metathesis reaction in industrial purposes. So with that, this is the total outline of this session. So I will wait for few minutes if anybody joins, or if not, then I will continue this session from my side. As of all, like the previous one, I will upload this session in the YouTube, and you will get the link through the recording sheet every day, every week. And so I will, whoever will watch this, I request you to join in this session. It is a Saturday and weekend, every weekend Saturday 5 to 7 p.m. So try to join the session in the 5 p.m. and clear your doubt, and I will try to clear as possible as I can. And if you have any suggestion regarding this session to improve the quality of the session, you can also tell me in this live session. Also, you can mail me to my email address. I will happy to improve the quality of this session using your feedback. So I will wait for another 1 or 2 minutes, then I will start discussing this session through this problem solving approach. Okay, let's start this session through this problem solving approach. Okay, welcome again. The transition metal organometallics in catalysis and biology live interactive problem solving session This is a week 4, 15 Feb 2025. So myself, Shubhajit Kundu, as an NPTEL PMRF TA for this course, I have given my email address. So if you have any suggestion, you can email me, or it is better to join this session live on every Saturday 5 p.m. to 7 p.m. and get your doubt cleared, or you can also post your doubt in the discussion forum regarding the course content, or course content. We are trying to answer those as quickly as possible. Okay. So first question of today's discussion series is that the products of the following reaction is. So we have seen that in olefin metastasis reaction, the intermediate is a metal carbene complexes, and depending upon the electrophilicity behavior of this carbene, or the nucleophilicity, or the substituent on the carbene, or the structural features, we have seen the several types of carbene. So one of which is this type, that is the N heterocyclic carbene, which is an imidazole based carbene, where the carbene atom, carbene carbon is stabilized by the push pull effect by the adjacent to nitrogen. Also, this carbene carbon act as a nucleophilic in nature, and this carbene also stable under room temperature and also water level. First synthesized by Arduengo in 1991. Okay, so when mercury act as a mercury acetate, here it is given. So you know that this molecule, that is that this molecule is called at a carbene precursor. That is, this type of carbene called N heterocyclic carbene. So this is called a N heterocyclic carbene precursor. Because any precursor means that is the one step behind the original product. So NHC precursor means this is the one step behind the NHC. So here you can see there is a acidic hydrogen. Because of this presence of two nitrogen atom, this proton or hydrogen is highly acidic in nature. As soon as it gets a base, it will take off, and then it will form the corresponding carbene complexes. Now we have the mercury acetate. So in all the system, that acetate generally act as a non-coordinating ligand. So here also normally act as a, or the O minus in the acetate ion also may act as a coordinating ligand. But here in presence of mercury acetate, as you see that this olefin or this carbene mechanism undergo depends on the substituent on the nitrogen. So here only the 2-phenyl ring is there, which is not so bulky in nature. That's why it is form a dimeric complex or bis n heterocyclic carbene complex. So here the acetate ion, that is ACO minus, will act as a base to abstract this imidazole CH proton and then the formation of subsequent carbene. So this will be formed as a carbene, and the correct answer for this question will be this A. Option A will be the correct answer. So because of the very small substituent, that is a phenyl, it generally form a dimeric complex with the mercury. So this option A will be the correct answer for this question. So here it is written products, but here only one product will be obtained. The next question is, this question is very important question, and this is also a tricky question, I can say. So the question says the total number of plausible cell metastasis product that can be obtained in the given reaction is. So this question is can be with the same reaction, there is a possibility of forming two questions. So in this reaction, so it is saying that self metastasis. So self metastasis, and the elimination is only C2H2, that is the acetyl. So in the self metastasis reaction, it means that the metastasis reaction is happening. So if you react R1 and if you react R1, so here the formation of this R1 will be one product, that is R1, this will be one product in the because of the cell metastasis reaction, and from the R2 it will be R2. This is also cell metastasis. So with this you can think that the possibility of product will be 2. You can may think because of the these two are the only cell metastasis product. But we can see if R1 or R2 are different and these two group contain can be any atom, so this orientation of the R1 R2 can be changed. So depending upon the cross metastasis product from the R1 we can also have R1 this type product. Also from this we can have R2 that is this product. So that means the cis isomer as well as the trans isomer from both the alkene is possible. So total number of self metastasis product only, not the cross metastasis. If it perform the cross metastasis, then R1 R2 is possible. Also R1, that the another trans isomer of this is also possible. So these two will be the another product. Okay, but here in this question we are only discussing about the self metastasis product. That's why our answer will be 4. So only 4 product R1 and R2 with the both cis and trans configuration will be our product. But if this question asks the total number of product, if we cut this option cell metastasis, total number of product only to obtain from this reaction, then our answer will be 6. So this question is a very interesting question or important question from this school. So when you are answering this question, so it is very important to read the question each and every word and understand the word behind this. So if you read the question as total number of total number of products can be formed in a given reaction, so you may be calculate and do the formation of all the product. Okay, and you will take out the 6 product. But in this question you are only considering the self metastasis product, not the cross metastasis product. Okay, so self metastasis product will be only 4. So 4 will be the correct answer for this question. I think this question is clear. If you have any doubt regarding this, you can ask me in the next step. With this, I am moving to the next question. The next question is a straightforward question which I discussed in the last week as very simple, or the okay. So this question is a type of explanation type of question or self workout question. So in the last day, at the end of the last days, in the end of the last days discussion, last day's topic, I have seen that I have discussed several types of several kinds of metastasis reaction. So this is now we have given one example among these, and we need to find out what kind of metastasis reaction is it. So let's say if you don't know the type of the metastasis reaction, or you may know but not totally remembering that all the types exactly with the example, so you can still work out this question. So the first is ring opening metastasis polymerization. So the first option says that ring opening metastasis. So as we all know that the ring opening metastasis is only possible when there is a ring. So here we don't have any ring, it is a linear chain and formation of the linear chain polymer also. This is not a ring. So as I told earlier also, the option elimination can be a very powerful tool to to go closer to your correct answer. So option A is not possible. You can first cut out this option. Then the acyclic diene metastasis polymerization. Is this acyclic? Is this acyclic? Yes, this molecule is acyclic. Is it a diene polymerization? Yes, it is a diene formation. We have the formation of diene. It is a metastasis reaction. Yes, it is a metastasis reaction. Is this a polymerization reaction? Yes, it is a polymerization reaction. So option B is the correct answer from this question. Now, as I also said that, so if you get the correct answer in first and second option, don't forget to read the all the options, because it is very important when you are answering MSQ, multiple selection type questions. This is very important for it. So for that, we have the self metastasis reaction. No, because self metastasis reaction we have already seen. This is the self metastasis giving the product R1 R1. This is not a, this is a kind of polymerization reaction. This is no self metastasis. So also the cross metastasis, no, because we have only one substrate. So in the cross metastasis reaction we should have at least two substrate. Okay, we should have at least two substrate. So this is not a cross wall metastasis reaction. So simply by eliminating the option, if you forget the type, just you have an idea of what was the different types of polymerization reaction during metastasis chemistry, you will get your answer. I think this question is very clear, and if not, we will discuss the different types of metastasis reaction in the previous day. We already discussed it. You can see it. Let's see whether it is there or not, or it will be there in the last day's video. Taking long time to open. Anyway, the next question is, oh, it open. No marking is there. So no marking is there. Okay. The next question is the given it is done. The next question is the reaction in which the cross metastasis observed is. So this is this week assignment problem. So this week we have started reading the cross metastasis reaction, and we have completed 2 lectures totally on cross metastasis reaction. Cross metastasis reaction is a powerful tool to obtain the multiple product with having the two different alkene. Okay, so this is happens not in the Reppe synthesis. You can also cut it. Chope reaction and the Phillips triolefin we have not read yet. So this will be the process for the Chope process. The cross metastasis reaction. Then what is Chope? Chope. So right now we are only talking about the small olefins or ethylene or small olefins. But if you have larger olefins obtained from the cracking of the petroleum, then the cross metastasis reaction is important to get the desired product. But there is a limitation of cross metastasis, that during the cross metastasis multiple product formation obtained, and their separation and isolation is very difficult. So because of the non-selectivity, you can say, because of the non-selectivity for the product formation, cross reaction polymerization is not that much applicable. But in larger aspect, if you modify the process little bit, then using some process, sequential process, we will discuss it later. We will also discuss this in this last lecture of this week, the how to control the modify the cross metastasis reaction using this SHOP process. The SHOP process will be the right answer, where is called the shell. We have now dealing with the higher shell. Higher O is for the olefin process. Okay, so this process we are having cross metastasis reaction. SHOP process is the right answer for this question. The next question is the reagent that generates carbene in situ. Sorry, this is not in situ, it should be in situ. In situ, in or are. So carbene is, we know that main metal is bound to CH2. If the metal is bound with CH2, that means the generation of carbene. Now CH2 we have to generate. So first option is CH3 NH2. So that is a methylamine. This methylamine generation is not possible. Another is the CH2 double bond CH2. Also breaking the ethylene bond is also difficult. The last one is HC double bond to H, that is the formaldehyde. There is formaldehyde is also breaking this OH bond is difficult. The last remaining option is option number C, that is CH2N2. Now this molecule have a high tendency to generate the carbene. Why? Because this has a N2 present. Now this N2 has high leaving tendency to liberate as N2 gas, which is the driving force for the formation of this reaction. So if you want to generate the carbene or CH2, metal bound CH2 in situ, you just take the diazomethane, that is the CH2N2, and you give it in the reaction mixture and heat it, and the nitrogen will evolve, nitrogen will release, and the carbene will generated in situ, and it will bind to the metal or any other Lewis acid. Okay, since for the generation of in situ always we use the diazomethane. Other molecule are highly stable and it cannot generate the carbene. With that, I completed the half of this today's discussion session. That is the question number 5 of today's discussion session. Okay. This question is also very interesting, and this question can be answered also by the simple logic. Now we have seen that synthesis of Graf's catalyst. So this is called the ruthenium carbene intermediate, ruthenium metal carbene intermediate to facilitate the olefin metathesis reaction, and Graf's catalyst, that is the ruthenium based catalyst, is one of the useful tool to do this catalyst, which is easily possible to make, air stable, and also the functional group tolerance. So the 3 point 1, 2 and 3, which makes the ruthenium metal complex or ruthenium carbene complex as a very good synthetic or suitable for the Graf's catalyst preparation or Graf's catalyst. Now there is a two fact in during the mechanism of the olefin metathesis using Graf's catalyst. We also discussed that. One thing is that coordinatively unsaturation, coordination, unsaturation, and 2 নম্বর হচ্ছে, and the number 2 is steric effect. Steric effect. Now you can see that in all of these molecule we have the coordinative, the steric effect is comes from the bind pH3 or PCOI3 ligand. Okay, PCOI3 or PPH3 ligand. The lability of this group, it depends on the steric effect. and now the coordinative unsaturation lead to the this chloride, bromide, iodide. This is the only three to make this complex coordinatively unsaturated. Also, the PCI3 also make it coordinatively unsaturated. Now, to remove or attack the substrate, we can see that the activity depends on the uh, removal of the halide group and now because of the thing activity of the activity of the chloride will be more than the corresponding iodide, and iodide the complex living tendency will be very much non-facile, so the Grubbs catalyst is only suitable for this chloride only. With that chloride, that is option B, will be the correct answer for this question. So option B will be right answer. That is the chloride will be more active, then followed by the bromide and followed by the iodide. Grubbs also makes this catalyst with the chloride one to have the maximum activity of it. With that, I go to the next question of today's discussion session. Next question is the product of the given reaction is. So this question is also a very important question, or just to improve the simple knowledge, or you can get this question. Now we have our Grubbs catalyst, that this is the Grubbs first generation catalyst. The second generation catalyst is the one of the PPH3 is substituted by the NH3 ligand, that is N Vu PH PPH3 Cl, and this one is methyl also, which I was discussing later in the last question, that the steric effect, this is the steric, this side and also this side, the steric effect also called the reactivity of the, this is the Grubbs second generation catalyst, where the control, that is the aspect of sterics demanding increases because of the this rotating methyl group and the substituted of the nitrogen. So first step is the PPH3 dissociation step in the Grubbs catalyst. So we have seen that PCI3 is more donating or more sterically demanding. So if you react this PCI3 instead of PPH3, so it will be easily rotate. So this is the grasped second generation catalyst. So what will happen this, only that PCI3 ligand will replace the remaining two PPHC ligand. Here two PCI3 we are using, so both the PPHC triphenyl phosphine ligand will replace and form this the corresponding complexes. So here option B, this will be the right answer for this question only. Nothing will happen. The next is the question number 8, the correct statement about the shock carbene complexes. So you have seen that there is a two types of carbene, majorly isolated discovered by Short and Fisher. So when the carbene is, that is when the carbene are it attached to the metal, okay, when the carbene, let's say we have M, we have double bond, we have X, we have CX. Now if the carbene, it is the Fisher type of carbene, we have only metal to ligand, let's say OR and OR, or it may be hydrogen also, okay, but one of the atoms will be heteroatom. We will call it Fisher type of carbene. Okay, so Fisher type of carbene, and we have seen that Fisher, in the last class we have discussed the Fisher type of carbene, what is the characteristic feature. So that is what is electrophilic or nucleophilic. So Fisher is, so A, B, C, E, E, F. So E and F is close to each other. So Fisher type of carbene will be electrophilic in nature, okay, because E and F are close to each other. Whereas the shock type of carbene only contains the substituent only hydrogen or carbon, no heteroatom. And the other types remaining, it is nucleophilic in nature. So this is nucleophilic in nature. That is the shock type. Shock type is nucleophilic in nature. Now the question is, so we have discussed two types of carbene. Now the question is about the shock type. So shock type of carbene only. So this is the chromium C. The C এর সঙ্গে one substitution is oxygen, another substitution is carbon. So shock type only hydrogen and carbon, no heteroatom. So this is cancelled. This is not the shock type carbene. Shock carbene complexes are formed with metal at the higher oxidation state. Now how to remember this one? Let's say the shock type of carbene is nucleophilic in nature, okay, so that means it has electron rich, and the same reverse explanation will be applicable for the fissure type also. So the shock type carbene is nucleophilic in nature. That means it has an electron rich carbene. So electron rich carbene will always try to donate an electron to where the electron is highly deficient. Okay, as the electron is highly deficient, so it will always try to bind with the metal which are high oxidation state. That means if you are rich, you are going to donate your thing. That means the shock type of carbene is electron rich, nucleophilic. It will donate or bind with the high positive charge metal. That means metal with high oxidation state. So option B will be correct answer for this question. As I said earlier that don't stop yourself when you got the correct answer or one correct answer. Try to go with other options also. Okay, so you have seen it. Now the next question is shock carbene. Shock carbene complexes are nucleoelectrophilic in nature. Shock carbene is electrophilic in nature. No, shock carbene we have said that it is nucleophilic in nature. So this is also the wrong answer. And the last answer is shock carbene complexes are nucleophilic in nature. Yes, shock carbene are nucleophilic in nature. So option D will be the correct answer. So now you can see that we got the answer to the 2. That is, this question is a type of MSQ, that is multiple selection type, multiple selection question. So for the MSQ question or MCQ also, you always try to read all the question, whether you find your options in first A or B. That doesn't guarantee that it will not have any other option. Okay, I think this discussion for this question is enough. Now I am moving to the next question today's discussion series. Next question is the product in the following transformation is. What will be the product for this following transformation? What will be the product for this following transformation? So we have seen that we have a diazomethane. The diazomethane we have already discussed in the our previous thing that it helps to generate carbene in situ. Okay, it helps to generate the carbene in situ because with the CH2 into this nitrogen will liberate as a N2 gas to generate the CH2. Okay, now we have the 3 phosphine ligand bound with the osmium center as all of you know that phosphine ligand is not stable. So it will generate the metal carbene species. Okay, so which will be the right answer? So obviously the PPH3 will be leaf and it will from the carbene species. So with the option C we can see this will be the correct answer for this question. Here the chloride is leaved, as chloride is leaf, so this is not the correct. Here what happened, the nitrine formation, that is the nitrogen bound product obtained, that is also not correct. What happened here, the NO leaf, no, the binding of NO is highly strong than the PPH3, so PPH3 will leave, not the NO. So option D will also be the correct answer. So option C will be the correct answer for this question. The next question is, this is the process of shop process. See, higher olefin polymerization, the shop process. Now the substrate of the following reaction is or are. So here the molybdenum aluminum oxide acts as a catalyst in this reaction. Okay, so we can see that we have, so as this is a olefin polymerization, olefin poly or olefin polymerization or olefin metathesis reaction. So we can easily discard these two options which have an alkyne group. So alkyne, we read it in Reppe process. Reppe. So this is not the Reppe. So if we see carefully, we have CH3, we have C1021. So C1021 is this and CH3 is this, and this is an example of cross metathesis reaction. This is an example of cross metathesis reaction. So what will happen here? Okay. So what will happen here? C10H21, CH3CH3. Okay. So we have C10H21, C10H21, Cl not a hydrogen, and we have CH3. We have CH3H. Okay. Now what will happen? So this will react with this to get our cross coupled product. Okay. So what will be the product? If we do this cross and this and this, that is this and this and this and this. This is done by the cross metastasis reaction. This is an example of cross metastasis reaction. So what will happen? So what will happen? So it will from H C 10 H21 double bond CH3 H 2 molecule of this will form. Now go back to our question. We have CH3 and C10H1, so 2 molecule of this from these two substrates. So here also option A and option C will be the right answer. So this is an example of, I have already said, this is a cross metastasis reaction in the Shope process catalyzed by molybdenum aluminum oxide. I think this question is clear. Now we have, I think, the last question for today's series. The ethylene oligomerization step in Shope process is catalyzed by. So in the Shope process we have seen that because the cross metastasis reaction, in the cross metastasis reaction in the cross metastasis reaction you can see that the product which obtained can undergo self metastasis reaction, and it is very difficult to remove or separate the self metastasis product. That's why in industrially developed a process where this process of soft is carried out in sequential manner to get the selectively cross metastasis product. So before discussing the soap process, I want to just I want to explain what is the soap process and what is the importance of it. So now we have seen that the cross metastasis reaction. So in the cross metastasis reaction, so if we have the R1, R2 plus R2, R3, R4, so these undergo the cross metastasis reaction giving R1, and R2, R4. So this will be the product for it, R2, R4. So this is if happen between these two molecules, that is the R2 and this. So but it is also possible to have the another coupling partner, that is R1, it is possible to have R1, R1, R4 as well as R2, R3. So similarly these can have also, this compound can undergo the self metastasis reaction also. So this gives a series of products. So now in the industry we have seen that the long long chain long chain olefins or alcohols or these are converting as a soap. So the industry needs some soaps. That was a problem. So that is the soft soft detergents. And for the soft detergent we have to restrict the carbon number value, that is the C value of C12 to C18. We don't need the below 1, we don't need the higher of this, so we have to restrict this faucet. So for the strategy of this to perform the reaction where we can only get this polymer which is having the carbon in between C12 to C18. Now in the soap process we have three different process. Now from this olefin we have to do the 1-octane synthesis with the help of nickel catalyst. With the help of nickel catalyst, that is the oligomerization reaction, to have this octane synthesis, 1-octane. So that is the C8 polymer. Now C8 polymer undergo the isomerization to give the 4-octane. Okay, this 4-octane. After that it undergo the cross metastasis reaction to perform the with the help of ruthenium and to give the 2 tetrasin, that is the ruthenium catalyst to give this cross metastasis reaction to give. With that another we have the another partner, that is this one. This is 17 and this is double bond. These also undergo the isomerization reaction to give the symmetrical. This is 8 and this is 8. Okay, so these undergo the cross metastasis reaction using ruthenium catalyst to have this our desired product. This is 10 and this is 10, 11, 12, 13, 14. So this is C14. So our C14 used for the soft detergent. This is the SHOP. And in the soap process, first step we need the nickel catalyst to transfer this oligomerization. So this is undergo the oligomerization, then isomerization, then cross coupling reaction. So this is called the soap process. So in the soap process, first is the oligomerization step. Our soap process catalyst is nickel. So nickel used as a catalyst in this soap process of oligomerization state. With this, we completed the 11 question from today's topic. So in this course, we are mainly seen that we are generating the application of organometallic complexes in broad aspect, that is the larger synthetic positive. It can be the industrial application, it can be the academic application or laboratory application. So in the reprochemistry we have seen that industrial handling of acetylene. Also in the metastasis reaction we have seen the application in different process. The different processes. So in the further portion we will see the more and more application of the transition metal organometallic complex with in the application part. And now currently we are reading the cross metastasis reaction. So in the last day, we discussed the different types of metastasis reaction. That is the ring opening polymerization, metastasis polymerization reaction, ring closing, and so on. So in the upcoming examination, I will or we will discuss the different polymerization reaction of metastasis polymerization reaction using the different catalysis and their application, uh, or using the transition metal carbene complexes as an intermediate. So I think I have completed the total topic in this series of week 4. So see you in the week 5. So in this week we have completed the cross metastasis reaction as well. We have entered in the another topic, that is the cross metastasis reaction. Uh, in this uh, week we have completed our series of olefin metastasis reaction, which is started in the last week, that is the mechanistic study, and then the catalytic development approach, how to develop a catalyst depending on considering the defining factor like the steric and electronic. And after that we entered and another important topic of cross metastasis. So following days we will discuss more on this cross metastasis reaction, as well as we will try to solve some real problem, that is how this cross metastasis reaction helps to develop the different kind of important molecule. So I think this is all for today. If you have any queries regarding this problem solving session or regarding this session, you can directly ask me in the this live every Saturday 5 to 7 p.m. Try to join early so that you can discuss the doubt first, then we move to the problem solving session. uh, or you can, I have also shared my email address in the starting of this slide, so you can also email me, or also you can suggest me your feedback through my email if you have any, to improve this session quality, or how to improve this session for that better improvement of the learners from this course. At the end, I want to say this is a very advanced level course of organometallic chemistry, and because of this, most of the question may not came in the competitive exam like GATE or NET, but this is development of organometallic chemistry in the last 30 years or 40 years, which we are discussing. And so it will understand how the research is going on in the field of organometallic, and how important and one field of chemistry evolved from synthesis or from discovery in the laboratory to the application in the industry. With that, I thank everyone who will join this session, or who will watch this video in the YouTube. So if you have any question regarding that portal content or portal assignment, you can ask in the Q&A option. I also showed in the first day of this series, that is the week 1 series. Please follow that and ask your doubt from the portal question and assignment only. We will try to resolve it as quickly as possible. If you have any doubt with this session or this session question, you can directly email me or directly ask me in live from 5 to 7 p.m. every Saturday throughout this course. With this, I thank everyone. I will close this session as nobody joined. Thank you for watching from the online mode. Bye bye.